Welcome everybody, my name is Alejandro López-Rey and today I'm going to talk about hardware and software solutions for an efficient thermal scanning mobile robot. The use of robots facilitates the creation of 3D models of buildings as it reduces the time required and improves the accuracy of the data collected. In the case of thermal digitization, thermal scanning platforms allow the monitoring of buildings by providing 3D points of the envelopes of the building at their corresponding temperatures. With this, you can create a thermal point cloud. In this presentation, limitations and issues regarding thermal scanning platforms are described, and a new platform that solves some of these limitations is proposed. The hardware limitations found in thermal scanning platforms are autonomy, whether the platform can navigate autonomously or it is commanded. The possibility of multiple sessions also refers to the autonomy of the platform. The scene and its characteristics come with several restrictions such as flat floors without stairs and no multiple floors. The limited field of view is an issue as it makes the thermal point cloud incomplete. Another issue is power consumption restriction, which imply a restriction on the time of use. Width and dimensions implies that any heavy or large robots are difficult to take to real environments in building interiors. And finally, cost is usually high when considering terrestrial robot bases or really accurate 3D sensors as laser scanners. In software limitations, we can find robot programming. Bibliography shows that most of the thermal scanning platforms are implemented under ROS. Sensors programming is the external sensor must be integrated in ROS, and some specific tools such as software development kits are required. Multi-session programming, there are just a few cases in which the robotic platform performs multiple data collection during a period of time. Also, working with millions of points implies that memory problems have to be taken into account. And finally, there are no works in which user interface is used. And user interface in thermal scanning platforms facilitates the use of the platform. On the right side, you can see Mopad2, a new thermal scanning platform. It is built on a low-cost and reduced-size Kabuki robot base. This mobile robot is implemented in ROS. With the RGBD camera and the laser rangefinder, localization and navigation issues are solved. This robot can charge autonomously, thus multiple sessions can be carried out. Thermal point cloud are captured using a Leica BLK 360 3D scanner with an embedded thermal camera. This system captures a panoramic image of 71 degrees. In order to increase the field of view, a pan-tilt platform is integrated. Through tilting 45 degrees, the scanner and omnidirectional point cloud can be generated. Also, as a power-saving measure, a switch actuator has been developed to switch off the scanner during idle periods. Most of the components in the Mopad2 are implemented in ROS. The components outside ROS, the scanner and the camera, have been programmed to work along ROS. All these different components are connected via Wi-Fi. There are two networks for communication and data transference. An app has been developed to control the parameters of the data acquisition, such as number of sessions, scanning positions, or type of data we want. An overview of the multi-session programming is shown in the next slide. There is an offline phase in which the map is obtained. This map is used for every session. The next phase is session definition through the app. Parameters are defined by the user. In the data acquisition, the robot navigates towards its predefined position and collects the data as planned. This phase ends when Mopad 2 docks at the charging station. Data acquisition is repeated for every session defined. In the data processing, several algorithms are carried out to obtain an omnidirectional thermal point cloud of the whole scene. In the video of the left, the docking for autonomous charging can be seen. After this, the platform waits for the next session. On the right, the robot is stopping at a scanning position. When it is oriented, the scanner is tilted to perform a data acquisition. These three videos are examples of the navigation capabilities of the robot. The first one shows how it can navigate through doors to get into different rooms. The videos on the right show different scanning scenarios, such as a palace with large spaces, or the scenario below with more narrow corridors. Mopad 2 has been tested in an apartment. A significant increase in temperature can be seen in window frames. Rooms with solar radiation have a higher temperature than the interiors one, as it can be seen in the video and in the picture. Both videos show the same building with the same color range. The thermal point cloud on the left was taken at 9 AM, and the one on the right was captured 2 hours later. It is worth noting the increase in temperature in the second session. Hotter zones indicates lights or sockets. To sum up, an analysis of thermal scanning limitations has been made. To overtake or reduce some of these limitations, Mopad 2 has been developed. There are some improvements in power consumption, autonomy, point cloud completeness, and especially in multi-session thermal clouds. However, some restrictions such as limited power capacity or the type of scene remain without solution. Future improvements can be made with the field of view and with visualization and functionality in the app.